All right, so we're going to finish section 10.2 today, and you had taken a look at a number of different types of displays of data, and the display of data that we're going to pick back up with today is called a histogram. A histogram is made up of adjoining rectangles or bars. The categories are shown along the horizontal axis, and the frequency is along the vertical axis. This is not called a bar graph. We are going to have a bar graph as well. But a histogram and a bar graph primarily differ based upon the fact that, number one, in the histogram, the bars touch each other. So you can make that as a note. The bars are going to touch each other. And the data is usually data that's on a continuum of values. It's not categorical data. It's some sort of a continuum of data. So like if you were looking at the ages of people, right, as your horizontal axis, or the grades, like the numerical numbering of grades on a test, a 95, a 96, a 97, kind of thing like that. So that's the kind of data you usually use in a histogram. So we're going to start by taking a set of data, and this is a set of data that you already did look at before when you watched the previous video. It's the grouped frequency table we did in example 5. And we're going to construct the histogram that shows this numerical distribution or disbursement from the data. And since I can't copy and paste it because I don't have it in here at the moment, you had something that looked like this. You had a 60 to 69, 70 to 79, it was 80 to 89, and 90 to 99. And I'm just going to use the frequency column and type it in, or write it in. And you had 3, 2, 4, 9, or it may be upside down from that when I did it in the notes online. This was the data from before, abbreviated. So we're going to use this data, and we're going to create a grouped frequency, or a histogram of this data. Oops, that's not what I wanted to do. That's what I want to do. There we go. So what you're going to do is you're going to create your horizontal and vertical axis, just like you have been on some of the other ones. It'll look like this. And you're going to label them. Along the bottom is going to be the grade. And I don't mean letter grade, it means like the number grades, because that's the grouped frequency table we're referencing. And then along the vertical axis is the frequency. And it doesn't have to go from smallest to biggest, but it feels sort of natural from what you're sort of familiar with doing already. So that's how I'm going to draw it. It could actually start with the largest values first and go downhill. It wouldn't be wrong. But it's kind of natural to make it like this. So you'd have 60, you'd mark 70. They need to be equally distributed. So whatever space you're using between 60 and 70 should be approximately the same amount of space between 70 and 80 and 80 and 90. It doesn't have to be perfect, but it shouldn't look really lopsided. Like this wouldn't be good, right? It would make it look like there's a lot more there than there really is. So here's the 100. And the frequencies that we're using over here on my table that I sort of shrunk over on the side go from 2 up to 9. So we need to mark out each of those. And you don't necessarily have to label every one of them. I'll mark 10 of them. But I tend to label every couple of them. I think that's enough for some visual perspective on it. So that's what I usually will do. Like that. If you have a straight edge, it can be very helpful for drawing. There's going to be some places later on where we're really going to need a straight edge. So an ID card works really well. If you have one of those you want to grab out, or your license. We're wanting to create a bar that corresponds to the height of that particular set of data. So from 60 to 69, it's supposed to have a frequency of 3. So I want a bar that is at a height of 3. So it would look something like that. The next one is supposed to have a height of 2, so it looked something like this. The 80 to 89 is supposed to be at a height of 4. So we're somewhere in this sort of a perspective. And then I'm supposed to be at a height of 9. If you want to use graph paper for these instead of just drawing it freehand, you're welcome to do so. That's not a problem. But don't feel like you have to. If you want to use graph paper and you just don't want to go buy the graph paper, you can actually print graph or grid paper off from online as well. So it looks something like this. You can tell my bars are not perfectly evenly sized, but they're fairly close. So that's what we're shooting for here, something that's fairly close. As with everything you already saw, what am I missing on this one right now? I'm missing a title. I need titles on all my graphs. What could be a title for this graph? What is this information about? Yeah, grades from exam 2. Or something like that, right? So some kind of a title to indicate what it is we're looking at. So we're going to move into categorical data now. And so when we look at a bar graph, we're thinking more like categorical data. So much like a histogram, but they have spaces between the bars to depict categories. Okay, the categories are somehow different. Now, this is a little bit of contrived, like for the example we're going to do. So instead of writing it from 60 to 100, we're going to write A, B, C, and D. Okay, I mean, that's kind of, simplistic, but it is. I mean, when you go to a report card, right, your report card does not say you got a 92 or a 98. It just says A, right? It is a category at some point when we look at a report card or, your transcript or something like that. So that's going to be the example we're going to do. But you can use all sorts of other kind of categories as well. Maybe your categories split by classification, freshman, sophomore, junior, senior, right? Maybe your categories can split by station in life, married, not married. Maybe your categories are male, female. Maybe your categories are, over 30, under 30, right? All those kind of survey things that people give you, and then they want to give you those questions at the end that put you in these categories. This is what they're doing it for. They're trying to figure out, well, do people in this category of ages or income levels or whatever, do they have a different kind of perspective than somebody else? Okay, so this is a category kind of an argument, and in order to separate out the different categories, there's space between the bars. So it's very much going to look just like this one, but bars are going to have space between them, and instead of labeling numbers at the bottom, we're going to label the categories. So for us, for our example, we're going to be labeling the letter grades, A, B, C, D. And we would have an F as well if we had one, but in this particular set of data, it's all grades from A down to D. So we're going to have the same frequency, or the same XY axis, which includes frequency and grades that we did before, like this. And we're going to label them pretty much the same way. So this one's frequency.
Is that how it usually works with bar graphs? Categories?
Mm-hmm. Yeah, and otherwise they're actually, what you're looking at is a histogram. And people will inadvertently call a histogram a bar graph all the time. So that's not necessarily an uncommon thing either. Someone might be saying this is a bar graph, and technically it's not. But you can see how that could be used and it not be sort of feeling wrong. Yeah. So down here, we're going to label it grades. But the part that's actually labeled on the axis, like the units itself, won't say 60 through whatever. Just to keep it looking much like the last one, I'm going to put D first, and then I skip a little space, and then I put C, and then I skip a little space, and I put B, a little more space, and then I put an A. And then I've still got the numbers that go from 2 to 10. 2 to 9. So I would start with 1, and I'll go from 1 to 10. I guess I'll stop at 9 because I ran out of space. I made them a little bit too big, I guess. And like I told you, I usually label about every other one. Sometimes if there's a really big values, I might label every fifth one even. It's not really a hard, fast rule. It's just to give me some perspective as I'm drawing. So the first one is a height of 3. The second one was a height of 2. The B value was a height of 4. And then my A value is supposed to be a height of 9. So something like that. And we're representing the categories of grades instead of the continuum of grades. It's also worth noting that we created what over here felt like a very natural, breaking point. But if you were looking at sets of data that weren't about grades, you might have to make that natural breaking, there might not be a natural breaking point. You might have to make the breaking point yourself. So like think again about the surveys that tell you at the end, like select which category your age is in, and it puts arbitrary things like there, and you have to watch sometimes because are you at the edge of those little, things. So it'll say something like, under 18, okay, fine. And then you're gonna have like 19 to 25, and then it'll say like 26 to 34, right? So this continuum right here doesn't necessarily have to correspond to anything special, although ours made sense to do so because of grades being the topic of discussion. All right, the next one is called a double bar graph. A double bar graph can be used to make comparisons in data. So it's good for comparisons. When we're looking at our bar graphs and so forth, we're comparing something within itself, like the data to one another. This is comparing one set of data to another set of data. That's what a double bar graph does. And if you take a look, we actually looked at the back-to-back stem and leaf plot from earlier, and that back-to-back stem and leaf plot's what you're going to want to reference back to. So flip back to your back-to-back stem and leaf plot. I'm going to get my, I'm going to have to write it down again, I guess, because I don't have it here to copy. So it looked something like this that you had before from last time. So I'll draw it and I'll try to shrink it. Did I put biggest value on top or on bottom?
Bottom.
Bottom, okay. So it started with a 4, Laura?
Yeah.
In the middle here, 4, 5, 6, 7, 8, and 9. Okay. Okay, sorry about that. Okay, so this is what you had on a previous one. It had title and all that. We're going to use this information, and what we're going to do is we're going to create a bar graph that is a double bar graph for this. So what does that mean? Well, it means that when we're looking at the axes on the bottom, we're going to have categorical data, right? So there's going to be these breaks between them, but we're going to compare it piece by piece. So it's going to look something like this. I need this to shrink just a little bit more. I'll try that. That's still probably big enough for us to utilize the way I need to. So we have our bar graph. We have them labeled like we did before. Frequency on the left. And grades along the bottom. And again, we're going to think of it like letter grades. It's categorical because we're looking at a bar graph. And we'll start with the smallest value. This time I don't start with D's because there's actually F's on exam 1, right? So I need some category space for F's. So it'll look like this. My categories will be a little bit smaller. There'll be 2 bars here, and this will be like the F. I don't need to put it necessarily like this, but it's your sort of grouping that all of this is the F's. And then we're going to give some space. And then this space is D's, and then there's a little bit of space, And this one is C's, and then there's a little bit of space. We have B's. Now I'm running into the word grade. Let me see if I can slide it up here. And then I have a little bit of space. And it's going to be fine when I move it over, so give me a second. I know I've written on top of that now, but just pretend for a moment I have not. Okay, that's good enough. Move it back over. Okay, I think that'll work. And I had A's here. Okay, gracious. Okay, on the first test, how many F's were there? 2. What is the biggest value on the first test of A's, B's, C's? I mean, what is your largest?
On the first one?
Yeah, I don't mean the largest value, but the largest number of values.
9.
I think that's exam 2 you're looking at, but that's
Oh,
okay.
right.
There's 9 of them on exam 2. I think it's right here on exam 1, right? 6 of them?
Yeah.
Okay. So the height of my bar graph needs to go up to 9, and that doesn't need to go any higher from exam 1 because it also tapped out at 6, which is smaller. So how many F's were there on the first test? What did we say? 2? 1?
1.
3? I think there's 3. All of these are actually F's. So there's 3 of them. They're just grouped in different categories, like because we broke them apart by value 10. So there's 3 of them. How many F's were there on exam 2? None. Okay, so we're going to skip over it. The exam categories for the F look a little weird, but let's look at D. How many D's were there on exam 1? 1. D's are the 60s. There's 1 of them. So over here in the D category, I have 1 D. It would look like that. And then with the D's in the second exam, that one is 3. So I need this to be at a height of 3. How many C's are there on the first exam?
3.
I think 4. I have 4 written down. Is that right?
Yeah.
There's 4. It's okay. And then the C's on the second exam is 2. So it's 4 and 2. So I need a height of 4 next to the height of 2. Right. B's on the second exam was 6, and on the first exam it's 4. So I have a height of 6 next to the height of 4. And then A's in the first exam is 4, and then 9. So we have it at 4. That's more or less okay. And then our height of 9. All right, pretty good. It's hard to read this the way it's drawn. It just looks like I've got a lot of bars at the bottom. So the way that we differentiate this to make it easier to work with is colors. So you can pick a couple of colors, or if you don't have colors, you can do different kinds of shading. So if you're working with just a pencil, you can shade, for example, these ones in one direction, and the other one you can shade in some other direction like this, right? So that they're shaded differently. If you have colors, it works better, and I'll have colors when you get to the test for it as well. So I'll do all my first exams in pink. And then my second exams I'll do in blue. And this is typically how you see them drawn when someone does them in like the media to represent data like this. And so what we do when we're writing our labeling for this or our title for this is we talk about this being the first and second exam scores. Or first and second exam comparison if you wish. And we want to specify what the colors mean. So where each of these boxes with the colors filled in represents something. So there's my blue box. And then here's my pink box. And we talk about the fact that the pink box is the first exam. And the blue box is the second exam. Does that make sense? Okay. All right. Our last thing that we're going to take a look at is going to be a circle graph or pie chart. So I'm going to let you write down the details of this while I get you some compasses and protractor. Not protractors. Yeah, protractors, not compasses. That's the one I want, protractors. So a pie chart or a circle graph consists of circular regions partitioned into disjoint segments. This graph shows how parts are related to the whole. We keep coming back to that part to whole stuff, don't we? Okay. Okay, so there's a little bit of legwork before we actually can draw with these that we have to do to find out what we're going to use them to draw for. Can't get the cabinet drawer closed, so I can't get the chair moved over. Struggling. Okay. So our grouped frequency table that we had from example 5, the one that I've redrawn or rewritten down once, we're going to actually use that data and we're going to create a frequency or create a pie chart for that grouped frequency data. So that's the one that we had right here. So I'm going to move it over here so that we can have it as a reference point. Okay, so if you have the data already, you're in luck. If you didn't have the data, you would create the data that you were being asked to go with. And then we're going to create one additional column. It doesn't necessarily have to be done in columns and rows, but it works pretty nicely to do so. How many total test scores are there in this data set? No, like individual tests. 18. Like if you count the total frequency, it's 18. Is everybody good with that? There were 18 individual data points that we compiled into this data set, condensed form. And what we want to do is we want to figure out a couple of things. There's actually 2 columns. One column is going to be the percent column, and the other one is going to be the degrees column. Okay? As in degrees of a circle. So what we're going to do is we're going to take each value and divide it by 18. So grab your calculator if you have it with you there. Grab your phone for now if you wish otherwise. So if you have 3 over 18, and then we want it as a percent, which means you need to multiply by 100, right? So 3 over 18 times 100. What do you get in a nearest whole percent? We're going to round whole numbers. 17%. And if you do that same 3 over 18 And instead of wanting the percent, you want the number of degrees, you multiply it by 360. Okay, so the same 3 over 18, but now we're going to multiply by 360. What do you get? It's 60. And we're going to do this for each of our 4 values. So now I'm going to do 2. We're going to do 2 over 18 times 100. And we're going to do 2 over 18 times the 360. So what is the percent?
You wrote 2 over 8 in the percentage column.
Thank you. What is my 2 over 18 as a percentage to whole numbers? 11%. And what about as the degree measure?
40.
It's a 40. The next one is 4 over 18, so it should just be double the previous one, right? It could have a measure of error depending on how things were rounded, but I think it actually works out here just to be perfect. So what is the percent? It is 22?
Yeah.
Good.
80 degrees.
And 80 degrees. Okay, so 4 over 18 times 360. And you don't have to write out all the formulas I'm writing, but that's where they're coming from. The last one's the easy one. What's 9 over 18? That's 50%. And if we do 9 over 18, or 50% of 360, what do we get? 180. Okay, in terms of drawing the picture, you need the degree measures. It's supposed to be a highlighter. You need these degree measures to draw the picture. But in terms of labeling your diagram, what you need is you need these percentages and the letter grades, which I have failed at this point to write in. But this is D, C, B, and A. So these pieces that are in green are going to either be labeling, right, or they're going to be used to draw the image itself. So I'd like for you to take something round next to you. Most of you have a cup or something on your table, or next door to you somebody does. And I'd like for you to draw a circle. Okay? So trace along the bottom of a water bottle. There's actually a bottle right here too if somebody wants to use it, and trace along the bottom. This one looks perfect actually. So if you need something to trace with that one, draw yourself a circle. And just mark the approximate center of your circle. It's not going to be perfect, but it'll be good enough. It's not even my cup, I don't know. Yeah. Okay, so because this one has a really nice 50% one, we're going to start with the 50% one on our diagram because it's easiest to draw. And we're going to cut our diagram in half, straight through the center. I don't care if you cut it up and down, left and right, at a diagonal, it doesn't matter. Half of that represents the 50%, which is the letter grade of A. So write it in there somewhere and write the 50% mark. The A and the 50% go into the charge. Okay? If you want to write the 180 degrees, you can, but you definitely don't need it in there. The size of your shape already determined that. Okay. Now, your protractor is what you're going to use for the other pieces. You need to go in order. For example, I do not need my A attached to my C. Right? A goes to B, goes to C, goes to D. So A is going to end up touching the B and the D, but it's not going to touch a C. So we're going to go in order. I'll go to B next. It's saying that my B is supposed to give me an 80-degree mark. Okay, so here's how we measure with protractor. So I'm going to try and do it so that you can see it from my screen here, because if I put it on the screen on the board, you're not going to be able to see it at all. Okay, the dot in the center, wherever your dot in the center is what lines up on the dot of the center of the circle. Okay, so line that up in the middle of the circle. And you're going to make sure that the line that's going straight through the middle of the dot, that straight line right through there, is along the edge of the center, like your radius, okay, or the diameter. And the numbers, if you go from the left around, you see there's a 0, 10, 20, 30, and there's also a 180, 170, 160, 150. They go up and they go down. You want to use the ones that are going up, and you want it to go all the way up until you get to 80, because ours is supposed to be 80 degrees. Okay, so do you see how they're labeled 0 and up, and then 180 and down? We're going to do the 0 and up.
Oh,
so you're going to go all the way to the 80. Now, whether it's inside the circle or whether it's outside of the circle, just on the edge from your protractor, you're just going to make a mark. Let me use the tiny one. So if I'm lining mine up right here, it's not going to be very nice when somebody watches this video later, but there's going to be an 80 mark, and it's going to be about right there. Okay, mine is actually on the top of my screen. I've got all sorts of string marks now, but it's on the top of that screen. And then you use your protractor edge that's got the straight edge, and you're going to line up the dot in the center with the dot that you made on the edge. And you're going to draw a line between the two. I can't do it. I got to do it with the straight edge from inside the device. Sorry. So you're going to line them up. So it's going to look like that if you actually attached it all the way to the dot on the outside, wherever it is. But you can just stop shy of that. You can just stop on the circle itself if you wish. Okay? And if you've drawn it well, it will be 80 degrees right here, right? That's the 80 degree marker that you've just used. The B is supposed to be 80 degrees, which was supposed to represent 22%, I believe, correct? Okay. C. The C value is, let's see, 11%. It's a 40 degree marks, right? So you're going to do the same thing, but what you're going to do is you're going to take your protractor and you're going to line it up along the radius you just drew. So on this screen, it's going to end up looking like it's going to be labeled like this, okay? The dot goes in the middle where the dot was before, but the edge that you were lining up before like this gets tilted at an angle, and it will line up along the edge you just drew. And that's your starting point now for starting from there to draw out 40 from there. So it looks something like this, right? The dot's in the middle, and then your 40 mark is going to be somewhere over here instead now. Oops. Something like that's what mine looks like. It's probably not real great, but. And then you're going to attach it again. And that's going to be C, which was 11%, right? Mm-hmm. And if you've done it well, it's arguable from my picture up here whether I have or not, because I keep having to touch the screen funny. This angle right here should be what's remaining, which is supposed to be 17%, 60 degrees. This should be 60 degrees, and you're welcome to measure it to see how close you are. Right, again, you would just move your protractor. You have a couple of options. You can either move your protractor so that your dot's in the middle and your line's now along the radius you just drew, and you can measure out from there to see if you're at 60. The other way you can do it is you can put your center right where it was before, and then you can measure from the left around, but still measuring from the 0 up and see if you're at 60. I don't think mine is, but hopefully yours is better than mine. Actually, it's pretty close. That's nice. Okay, so again, the 60 degrees doesn't need to go in here, but the D does, and it needs to say 17%. A word of advice or comment here anyway. The percentages that I just marked, they should add to 100%. But if they didn't, why would that be potentially okay still? Because we rounded, right? So if we didn't do any kind of rounding whatsoever and kept all of our decimals as long as we possibly could and or kept repeating values and things like that, it would be perfect and it would add up to 100 degrees. I'm sorry, 100%. It may not do that if we've done some rounding along the way. And in fact, I think that this one, does it work? This one does. This one actually adds up to 100%. So this one ended up rounding nicely. What do I need? One more thing I need on this graph. I need a title. What do you think my title should be? Yeah, so it don't even have to do the percent. It's represented in percents. If you want to write percent, you can. But these are still grades. It's just grades from a different representation, right? Grades on exam 2 or a second exam or something like that. What this does that the previous ones do not do a very good job of is it allows you to see very quickly, oh man, look at the way that these grades compare to one another. I mean, can you see it over here? That one? You can. You can see the comparison, but you can see the comparison as it compares to one another, right? You can see how A compares to B, compares to C, compares to D. Here you can see how it compares to the entirety of who took the exam, right? You can see at a glance, oh, half of the people got A's, right? You'd have to actually think a little bit harder about that on the other one. You wouldn't know it's half. You'd know a lot more people got A's, but you wouldn't know it's half exactly from a glance. Here you can see this at a glance. You could say from a glance, oh, look, almost a quarter of the people got B's, right? Almost 1/4 of them are B's. You could look at this very quickly and say, oh, look, almost 75% of people got A's and B's. I mean, it's close, right? You can make a lot of decisions based upon how it's comparing to the whole instead of just comparing part to part.